Question 1. Consider a scenario where during the final stages of developing a new web application that will handle sensitive customer data, a security audit reveals a critical vulnerability in a third-party library used by the application. This vulnerability could potentially allow unauthorized access to user credentials. The project deadline is imminent, and delaying the launch would have significant business consequences. The development team has identified a potential workaround that would temporarily mitigate the risk, but a permanent fix from the library vendor is not expected for several weeks. What is the most professionally responsible course of action? Option A. Halt the application launch indefinitely until the third-party library vendor releases a permanent fix, regardless of the business impact. Option B. Proceed with the application launch as scheduled, assuming the vulnerability will not be exploited before the vendor releases a fix. Option C. Deploy the application with the known vulnerability and instruct users to be extra cautious with their credentials. Option D. Implement the temporary workaround to mitigate the immediate risk, thoroughly test the workaround, and plan for the permanent fix to be applied as soon as it becomes available, while also notifying relevant stakeholders about the situation and the mitigation plan. Correct answer is D. Implement the temporary workaround to mitigate the immediate risk, thoroughly test the workaround, and plan for the permanent fix to be applied as soon as it becomes available, while also notifying relevant stakeholders about the situation and the mitigation plan. Explanation. This scenario presents a professional challenge because it requires balancing the immediate need for application functionality with the long-term implications of security vulnerabilities and compliance. The DEVCOR exam emphasizes developing applications that are not only functional but also secure and adhere to established best practices and regulatory frameworks. In this context, the challenge lies in making a judicious decision that prioritizes security and compliance without completely halting development. The correct approach represents best professional practice because it acknowledges the critical nature of the identified vulnerability and its potential impact on data integrity and user privacy. By immediately addressing the vulnerability through a secure coding practice and thorough testing, the development team upholds the principle of security by design. This aligns with general cybersecurity best practices within the context of U.S. regulations relevant to application development, such as NIST guidelines and potentially industry-specific regulations like HIPAA for healthcare data or PCI DSS for payment card data. Though these are not explicitly stated as the sole jurisdiction, the principles are universal for secure development, demonstrates a commitment to protecting sensitive information and maintaining system integrity. This proactive stance minimizes the risk of breaches and subsequent legal or reputational damage. An incorrect approach that involves deploying the application without addressing the vulnerability is professionally unacceptable due to significant regulatory and ethical failures. Such an action would violate the implicit or explicit requirement to protect user data and maintain system security, which is a cornerstone of most data privacy regulations in the U.S. This could lead to severe penalties, fines, and loss of customer trust. Another incorrect approach, which is to ignore the vulnerability and hope it goes unnoticed, demonstrates a severe lack of professional responsibility and ethical conduct. This passive approach actively disregards potential harm to users and the organization, failing to meet the due diligence expected of a developer. Finally, an approach that prioritizes speed over security without a clear mitigation plan for the identified vulnerability is also flawed. While agility is important, it should not come at the expense of fundamental security principles, especially when a known vulnerability exists. The professional decision-making process for similar situations should involve a risk assessment framework. Developers should first understand the severity and potential impact of any identified vulnerability. Then, they should evaluate the feasibility and timeline for remediation. If a critical vulnerability is found, the default professional stance should be to address it before deployment, unless there is a compelling, documented business justification and a robust, time-bound plan for immediate mitigation. This involves clear communication with stakeholders, including management and security teams, to make informed decisions that balance business needs with security and compliance obligations. Question 2. The investigation demonstrates that a development team building an application for Cisco collaboration platforms has encountered a critical security vulnerability during late-stage user acceptance testing. The team is under significant pressure to meet a hard launch deadline, Which of the following approaches best reflects professional responsibility and adherence to best practices for developing applications on Cisco core platforms? Option A. Implement a temporary workaround for the vulnerability that might introduce minor performance degradation and address the root cause in a subsequent release. Option B. Immediately halt the launch, prioritize fixing the vulnerability with a dedicated security sprint, and retest thoroughly before any release. Option C. Proceed with the launch as scheduled, documenting the vulnerability for a post-launch patch, assuming the risk is low for the initial user base. Option D. Delegate the responsibility of fixing the vulnerability to the operations team after the application has been deployed to production. The correct answer is B. Immediately halt the launch, prioritize fixing the vulnerability with a dedicated security sprint, and retest thoroughly before any release. Explanation. This scenario presents a professional challenge due to the inherent tension between rapid development cycles and the need for robust security practices, particularly when dealing with sensitive data. Developers are often pressured to deliver features quickly, which can lead to overlooking security implications. The DEVCOR exam emphasizes building secure and reliable applications on Cisco platforms, implying a responsibility to integrate security from the outset. The correct approach represents best professional practice because it aligns with the principles of Secure Development Lifecycle, SDLC, and the implicit requirements of developing applications for enterprise-grade platforms like those offered by Cisco. Proactively identifying and mitigating security vulnerabilities during the design and development phases is far more cost-effective and less risky than addressing them after deployment. This approach demonstrates a commitment to protecting user data and maintaining the integrity of the Cisco infrastructure, which is a core tenet of professional responsibility in this domain. It also reflects a proactive stance on compliance with potential future security mandates or best practices that might be introduced by Cisco or regulatory bodies governing data handling. An incorrect approach that prioritizes speed over security by deferring security testing to the end of the development cycle is professionally unacceptable. This failure represents a significant ethical lapse and a potential regulatory violation. It demonstrates negligence in safeguarding sensitive information, which could lead to data breaches, reputational damage, and legal repercussions. Such an approach ignores the principle of security by design, a fundamental concept in modern software development. Furthermore, it could violate implicit agreements or service-level objectives related to data protection and application security expected by users and stakeholders of Cisco platforms. Another incorrect approach that involves implementing security measures without understanding their impact on application performance or compatibility with Cisco core platforms is also professionally unsound. While security is crucial, it must be implemented thoughtfully and holistically. A poorly implemented security control can create new vulnerabilities or degrade the application's functionality, leading to user frustration and potential system instability. This demonstrates a lack of due diligence and a failure to consider the broader system context, which is essential for developing robust applications on integrated platforms. A professional reasoning process for similar situations should involve a risk-based approach. Developers must continuously assess potential security threats and vulnerabilities throughout the development lifecycle. This includes understanding the data being handled, the potential impact of a breach, and the relevant security best practices and guidelines applicable to the Cisco platforms being used. Collaboration with security experts, thorough code reviews, and comprehensive testing at various stages of development are critical. Prioritizing security from the initial design phase, rather than as an afterthought, is paramount to building trustworthy and compliant applications. Question 3. Upon reviewing the requirements for a new healthcare application designed to manage patient appointment scheduling and basic demographic information, which approach best ensures compliance with U.S. data privacy regulations and upholds professional ethical standards for handling sensitive patient data. Option A. Transmit sensitive patient data to third-party cloud storage services using standard HTTP protocols without explicit encryption, relying on the cloud provider's general security measures. Option B. Implement robust encryption for all sensitive patient data both at rest and in transit, establish strict role-based access controls, and maintain comprehensive audit logs of all data access and modifications. Option C. Focus solely on application functionality and user interface design, deferring detailed security and privacy considerations to a later stage of development or post-deployment. Option D. Store all sensitive patient data in plain text within the application's database to simplify data retrieval and reduce development time, assuming the application will only be accessed by authorized personnel. The correct answer is B. Implement robust encryption for all sensitive patient data both at rest and in transit, establish strict role-based access controls, and maintain comprehensive audit logs of all data access and modifications. Explanation. This scenario presents a professional challenge because it requires balancing the immediate need for a functional application with the long-term implications of data privacy and security, particularly within the context of U.S. regulations governing data handling. Developers must make informed decisions about how sensitive information is processed and stored, ensuring compliance with established legal frameworks. Careful judgment is required to avoid potential legal repercussions and maintain user trust. The correct approach represents best professional practice because it prioritizes adherence to the Health Insurance Portability and Accountability Act, HIPAA, and relevant state privacy laws. By implementing robust encryption for data at rest and in transit, and by ensuring that all data access is logged and audited, the developer is actively mitigating risks associated with unauthorized access or disclosure of protected health information. 5. This proactive stance aligns with the principles of data minimization and security by design, which are fundamental to regulatory compliance and ethical data stewardship in the healthcare sector. An incorrect approach that involves storing sensitive patient data in plain text, even with the intention of simplifying development, represents a significant regulatory and ethical failure. This directly violates HIPAA security rule, which mandates the protection of electronic PHI (EFI) from unauthorized access, alteration, or destruction. Such a failure could lead to substantial fines, legal action, and severe reputational damage. Another incorrect approach, which involves transmitting sensitive patient data over unencrypted channels to external services without proper vetting or contractual agreements, also constitutes a serious regulatory and ethical lapse. This exposes PHI to interception and potential misuse, violating HIPAA requirements for secure transmission and business associate agreements. The lack of due diligence in selecting and integrating external services further exacerbates the risk. Finally, an approach that neglects to implement access controls and audit trails for sensitive patient data is professionally unacceptable. Without these measures, it is impossible to track who accessed what data and when, making it difficult to detect or respond to breaches. This directly contravenes HIPAA requirements for access control and audit capabilities, leaving the organization vulnerable to both internal and external threats. Professionals should employ a decision-making framework that begins with a thorough understanding of applicable regulations, such as HIPAA. This should be followed by a risk assessment to identify potential vulnerabilities in the application's design and data handling processes. Subsequently, developers should prioritize security and privacy by design, integrating appropriate technical safeguards like encryption and access controls from the outset. Regular security audits and ongoing monitoring are crucial to ensure continued compliance and to adapt to evolving threats and regulatory landscapes. Question 4. The control framework reveals that an API designed to manage sensitive customer data is nearing its deployment deadline. The development team is under pressure to release the functionality quickly. Which of the following approaches best aligns with the regulatory requirements for secure and compliant API development? Option A. Focus on meeting the functional requirements and plan to address security concerns and compliance checks only after the initial release and before the next scheduled audit. Option B. Conduct a thorough penetration test immediately after deployment and address any identified vulnerabilities in subsequent patch releases. Option C. Assign all security implementation tasks to a dedicated security operations team, with minimal direct involvement from the development team during the coding phase. Option D. Implement comprehensive input validation, robust authentication and authorization mechanisms, and ensure data encryption in transit and at rest, integrating these security measures throughout the development lifecycle. The correct answer is D. Implement comprehensive input validation, robust authentication and authorization mechanisms, and ensure data encryption in transit and at rest, integrating these security measures throughout the development lifecycle. Explanation. Scenario analysis. This scenario presents a common challenge in API development within regulated environments, balancing the need for rapid feature deployment with the imperative of maintaining robust security and compliance. The pressure to deliver new functionality quickly can lead developers to overlook or deprioritize security considerations, especially when dealing with sensitive data. The professional challenge lies in navigating these competing demands, ensuring that security is not an afterthought but an integral part of the development lifecycle, and that all actions align with the established regulatory framework for the specified jurisdiction. Correct approach analysis. The correct approach involves a proactive and integrated security strategy. This means embedding security checks and validations directly into the API development workflow, from initial design through to deployment and ongoing monitoring. Specifically, this includes rigorous input validation to prevent injection attacks, proper authentication and authorization mechanisms to control access to sensitive data, and adherence to data privacy principles as mandated by the relevant regulatory framework. This approach represents best professional practice because it directly addresses the security risks inherent in API development and ensures compliance with the regulatory requirements. By making security a core component of the development process, it minimizes the likelihood of vulnerabilities being introduced and reduces the risk of data breaches or non-compliance, which can have severe legal and financial repercussions. Incorrect approaches analysis. One incorrect approach is to rely solely on post-deployment security scans and penetration testing. This is a reactive measure that assumes vulnerabilities can be identified and fixed after they have been introduced into the production environment. This approach fails to meet regulatory requirements for proactive security and increases the risk of exploitation before a vulnerability is discovered. It is professionally unacceptable because it demonstrates a lack of due diligence in preventing security flaws. Another incorrect approach is to implement security measures only when a specific compliance audit is imminent. This check-the-box mentality leads to a superficial and often inadequate implementation of security controls. It is professionally unethical and non-compliant because it prioritizes the appearance of compliance over genuine security, leaving systems vulnerable between audits and failing to uphold the spirit of the regulations. A third incorrect approach is to delegate all security responsibilities to a separate security team without involving the development team in the design and implementation phases. While a dedicated security team is crucial, a lack of collaboration means developers may not fully understand the security implications of their code, and security measures might be implemented in a way that is difficult to integrate into the development workflow. This can lead to inefficient security practices and missed opportunities for secure coding from the outset, violating the principle of shared responsibility for security mandated by many regulatory frameworks. Professional reasoning. Professionals should adopt a security by design and privacy by design approach. This involves integrating security and privacy considerations into every stage of the API development lifecycle. A decision-making framework should prioritize understanding the specific regulatory requirements of the jurisdiction, identifying potential threats and vulnerabilities early, and implementing robust controls that are both effective and maintainable. This includes continuous learning about evolving threats and regulatory updates, fostering a culture of security awareness within the development team, and establishing clear processes for security reviews and incident response. Question 5. Examination of the data shows that a development team is considering integrating a third-party API into a critical Cisco-based application to meet an aggressive product launch deadline. The team has conducted a cursory review of the API's documentation, but has not performed a detailed security audit or a comprehensive risk assessment of its data handling practices. The team lead is advocating for immediate integration to avoid delaying the launch. What is the most professionally responsible approach to this situation? Option A. Conduct a thorough impact assessment, including a detailed security review of the API and its data handling, and develop mitigation strategies for identified risks before proceeding with integration. Option B. Proceed with the API integration immediately to meet the launch deadline, and address any potential security or compliance issues that may arise post-launch. Option C. Delay the product launch to allow for an extended, in-depth security penetration testing of the third-party API, even if it means missing the deadline significantly. Option D. Integrate the API with minimal security controls, assuming the third-party provider has adequately secured their service. The correct answer is A. Conduct a thorough impact assessment, including a detailed security review of the API and its data handling, and develop mitigation strategies for identified risks before proceeding with integration. Explanation. This scenario presents a professional challenge because the development team is facing a critical decision point regarding the integration of a new API. The challenge lies in balancing the immediate need for feature delivery with the long-term implications of potential security vulnerabilities and compliance risks. A thorough impact assessment is crucial to avoid costly remediation, reputational damage, and potential regulatory penalties. The correct approach represents best professional practice because it prioritizes a systematic and documented evaluation of the proposed API integration. This involves identifying potential risks, security, performance, compliance, assessing their likelihood and impact, and developing mitigation strategies before proceeding. This proactive stance aligns with the principles of responsible software development and adherence to industry best practices, which are implicitly expected within the context of developing applications on Cisco core platforms. While the DEVCOR exam syllabus doesn't explicitly cite specific U.S. regulations for this context, the underlying principles of due diligence, risk management, and secure development are universally recognized as professional obligations. An incorrect approach that bypasses a formal impact assessment and proceeds with integration based solely on perceived urgency or ease of implementation represents a significant regulatory and ethical failure. This failure stems from a disregard for potential security vulnerabilities that could be introduced, leading to data breaches or unauthorized access. Ethically, it demonstrates a lack of due diligence and a potential disregard for the security and privacy of end users or the organization's data. Furthermore, it could violate implicit organizational policies or industry standards that mandate risk assessment for new integrations. Another incorrect approach, which involves a superficial review without deep technical analysis of the API's security posture or data handling practices, also constitutes a professional failure. This approach might identify obvious risks but fails to uncover more subtle or complex vulnerabilities. This lack of thoroughness can lead to the introduction of significant security gaps that might not be immediately apparent but could be exploited later. The professional reasoning process for such situations should involve a structured risk management framework. This begins with clearly defining the scope of the integration and the objectives. Next, a comprehensive impact assessment should be conducted, considering technical, security, performance, and compliance aspects. This assessment should involve relevant stakeholders, including security teams, compliance officers, and operations personnel. Based on the assessment, a decision should be made to either proceed with the integration, implement specific mitigation controls, or reject the integration if the risks are deemed unacceptable. Documentation of this process is vital for accountability and future reference. Question 6. Performance analysis shows that a new application designed to automate network configuration changes via Cisco APIs is experiencing intermittent failures and increased latency in production. The development team implemented the application rapidly to meet a business deadline, with minimal upfront analysis of its potential impact on existing network services and resource utilization. Which of the following approaches best represents a professional and compliant method for addressing this situation and preventing future occurrences? Option A. Focus solely on optimizing the code of the new application for speed and efficiency, assuming that performance issues are purely a coding problem and not related to its interaction with the broader Cisco environment. Option B. Conduct a comprehensive impact assessment to identify all affected systems, potential performance bottlenecks, security vulnerabilities, and operational overhead before proceeding with any further development or deployment of similar applications. Option C. Immediately roll back the application to a previous stable version and instruct the development team to rebuild it from scratch without any specific guidance on integration or performance considerations. Option D. Rely entirely on enhanced post-deployment monitoring tools to detect and alert on future issues without altering the current development process for new features. The correct answer is B. Conduct a comprehensive impact assessment to identify all affected systems, potential performance bottlenecks, security vulnerabilities, and operational overhead before proceeding with any further development or deployment of similar applications. Explanation. Scenario analysis. This scenario presents a common challenge in application development for Cisco platforms, balancing the need for rapid feature deployment with the imperative to understand and mitigate potential impacts on existing services and user experience. The professional challenge lies in the inherent tension between innovation speed and operational stability. Developers must anticipate how new functionalities, especially those interacting with core network services or APIs, might disrupt established workflows, introduce latency, or consume excessive resources. This requires a proactive rather than reactive approach, moving beyond simply building a feature to understanding its ecosystem. Correct approach analysis. The correct approach involves conducting a thorough impact assessment prior to development. This aligns with best professional practices and implicit regulatory expectations for responsible software development within enterprise environments. Such an assessment typically includes identifying all affected systems, APIs, and user groups, analyzing potential performance degradation, security vulnerabilities, and operational overhead. By proactively identifying and addressing potential issues, developers ensure that new applications integrate seamlessly, maintain service levels, and comply with internal policies and industry standards for reliability and security. This approach minimizes risk, reduces costly post-deployment remediation, and upholds the integrity of the Cisco core platforms. Incorrect approaches analysis. Implementing a new feature without a prior impact assessment is a significant regulatory and ethical failure. It demonstrates a disregard for operational stability and potential service disruption, which can have severe business consequences. This approach violates implicit professional obligations to deliver reliable and secure software, focusing solely on the functional requirements of the new feature, while neglecting its integration and performance implications, represents a narrow and unprofessional development methodology. This oversight can lead to unforeseen performance bottlenecks, increased support costs, and a negative user experience, all of which undermine the value proposition of the application and the underlying Cisco infrastructure. Relying on post-deployment monitoring alone to identify issues is a reactive and inefficient strategy. While monitoring is crucial, it should supplement, not replace, proactive impact assessment. Waiting for problems to arise increases the likelihood of significant service outages, data integrity issues, or security breaches, which are unacceptable from a professional and potentially regulatory standpoint, especially in environments governed by strict uptime and data protection requirements. Professional reasoning. Professionals should adopt a risk-based development lifecycle. This involves integrating impact assessment as a mandatory phase early in the development process. Key steps include: 1. Define scope. Clearly understand the intended functionality and its interaction points with Cisco core platforms and APIs. 2. Identify stakeholders. Engage with network operations, security teams, and end users to gather requirements and understand existing constraints. 3. Analyze dependencies. Map out all systems, services, and APIs that the new application will interact with. 4. Assess potential impacts. Evaluate risks related to performance, scalability, security, and operational complexity. 5. Develop mitigation strategies. Plan for how to address identified risks, including testing, rollback procedures, and resource allocation. 6. Document findings. Maintain clear records of the assessment and mitigation plans. This structured approach ensures that development is not only innovative but also responsible, sustainable, and compliant with professional standards. Question 7. Compliance review shows that a new application designed to analyze customer network traffic patterns for performance optimization is collecting and processing personally identifiable information, PI, without adequate safeguards. The development team is considering several approaches to rectify this situation and ensure regulatory adherence. Which of the following approaches best addresses the compliance requirements for handling sensitive data within the application? Option A. Process and store all collected customer data in plain text within the application's database for ease of access during analysis. Option B. Remove all PII from the dataset, rendering the traffic pattern analysis ineffective for its intended purpose. Option C. Grant broad API access to all application components and rely on network-level firewalls to secure the data. Option D. Implement granular role-based access controls for API endpoints and anonymize sensitive customer data, before it is processed or stored by the application. The correct answer is D. Implement granular role-based access controls for API endpoints and anonymize sensitive customer data before it is processed or stored by the application. Explanation. Scenario analysis. This scenario presents a common challenge in developing applications that interact with sensitive network data. The professional must balance the need for application functionality and data access with the stringent requirements of regulatory compliance, specifically concerning data privacy and security. The challenge lies in interpreting and applying the relevant regulations to a technical implementation, ensuring that the application's design and operation do not inadvertently lead to noncompliance. The risk of data breaches, unauthorized access, or improper data handling is significant, which can result in severe legal penalties, reputational damage, and loss of customer trust. Careful judgment is required to select an approach that is both technically sound and legally defensible. Correct approach analysis. The correct approach involves implementing robust access controls and data anonymization techniques. This aligns with the principles of data minimization and purpose limitation, which are fundamental to many data privacy regulations. By granting API access only to authorized personnel and systems, and by anonymizing or pseudonymizing sensitive data before it is processed or stored by the application, the risk of unauthorized disclosure or misuse is significantly reduced. This proactive measure ensures that the application adheres to the spirit and letter of the law, protecting individual privacy while still enabling necessary data analysis and application functionality. This approach demonstrates a commitment to responsible data stewardship and regulatory adherence. Incorrect approach is analysis. One incorrect approach is to grant broad API access to all application components without granular controls. This violates the principle of least privilege, a core security and regulatory tenet. It increases the attack surface and the likelihood of unauthorized data access or modification, leading to potential regulatory violations related to data protection and security. Another incorrect approach is to process and store sensitive customer data in plain text within the application's backend. This is a direct contravention of data security requirements mandated by most data privacy frameworks. It exposes the data to significant risk in the event of a breach and fails to implement necessary encryption or pseudonymization measures, resulting in severe regulatory noncompliance and ethical breaches. A third incorrect approach is to rely solely on network-level security to protect API endpoints, without implementing application-level data validation and sanitization. While network security is important, it does not address vulnerabilities within the application itself that could lead to data leakage or manipulation. This oversight can lead to regulatory noncompliance if the application handles sensitive information and fails to implement adequate application-level safeguards. Professional reasoning. Professionals developing applications that interact with sensitive data must adopt a risk-based approach to compliance. This involves understanding the specific regulatory landscape applicable to the data being handled, e.g., data privacy laws, industry-specific regulations. The decision-making process should prioritize security and privacy by design. This means integrating compliance considerations from the initial stages of development, not as an afterthought. When faced with choices about data access and handling, professionals should always opt for the solution that offers the highest level of protection for sensitive information, consistent with regulatory requirements and ethical obligations. Regular security audits, code reviews, and adherence to established best practices for secure coding and data management are crucial components of this process. Question 8. Analysis of a scenario where a development team is building a new application that integrates with Cisco network devices via APIs to collect network performance metrics and user connection logs. The application is intended for use within a US-based enterprise. Which of the following approaches best ensures compliance with relevant US federal regulatory frameworks governing data privacy and security for such an application? Option A. Focus primarily on optimizing API call efficiency and response times, assuming that standard network security protocols will inherently protect any collected data. Option B. Implement security measures only after a data breach incident has been reported and investigated. Option C. Conduct a comprehensive data privacy impact assessment (DPIA) and implement security controls aligned with NIST cybersecurity framework guidelines before deployment. Option D. Deploy the application immediately to gather initial data and address any potential privacy or security concerns that arise based on user feedback. Correct answer is C. Conduct a comprehensive data privacy impact assessment (DPIA) and implement security controls aligned with NIST cybersecurity framework guidelines before deployment. Explanation. The scenario presents a common challenge in developing applications that interact with Cisco core platforms and APIs, ensuring regulatory compliance, specifically concerning data privacy and security, within the context of U.S. federal regulations. The challenge lies in balancing the functionality and efficiency of API integrations with the stringent requirements of data protection laws. Developers must proactively identify and mitigate risks associated with handling sensitive information, especially when data traverses different network segments or is processed by third-party services. Careful judgment is required to interpret and apply relevant regulations to technical implementations. The correct approach represents best professional practice because it prioritizes a proactive, risk-based strategy aligned with U.S. federal data privacy and security mandates. By conducting a thorough data privacy impact assessment (DPIA) and implementing robust security controls, the development team demonstrates a commitment to safeguarding user data and adhering to legal obligations. This approach ensures that privacy and security are embedded into the application's design from the outset, rather than being an afterthought. This aligns with principles of privacy by design and security by design, which are increasingly expected and often mandated by regulations like HIPAA for health information, or general data protection principles applicable to sensitive personal information. An incorrect approach that involves deploying the application without a formal data privacy assessment and relying solely on general security best practices fails to meet the specific requirements of U.S. federal regulations. This approach risks non-compliance, leading to potential legal penalties, reputational damage, and loss of customer trust. It overlooks the nuanced requirements for handling different types of data and the specific consent or notification obligations that may apply. Another incorrect approach, which involves implementing security measures only after a data breach is detected, is reactive and demonstrably inadequate. Regulations often require preventative measures and incident response plans. Waiting for a breach to occur signifies a failure to uphold due diligence and a disregard for the potential harm to individuals whose data might be compromised. This approach is not only non-compliant but also ethically unsound. A third incorrect approach, focusing solely on API performance optimization without considering data handling implications, ignores a critical aspect of regulatory compliance. While performance is important, it cannot come at the expense of data privacy and security. U.S. federal regulations often place the onus on the data controller and processor to ensure data is handled securely and in accordance with legal frameworks, regardless of the application's performance metrics. The professional decision-making process for similar situations should involve a structured approach. 1. Understand the data. Identify what types of data the application will access, process, and store, and determine if it falls under any specific regulatory purview, e.g., PI5. 2. Identify applicable regulations. Research and understand all relevant U.S. federal laws and guidelines pertaining to the identified data types and the application's functionality. 3. Conduct risk assessments. Perform DPIA and security risk assessments to identify potential vulnerabilities and compliance gaps. 4. Implement controls. Design and implement technical and organizational controls to mitigate identified risks and ensure compliance. This includes encryption, access controls, audit logging, and secure coding practices. 5. Document and review. Maintain thorough documentation of compliance efforts and conduct regular reviews and updates to adapt to evolving regulations and threats. 6. Seek legal counsel. When in doubt, consult with legal experts specializing in data privacy and cybersecurity law. Question 9. Operational review demonstrates that a developer has identified a potential security vulnerability within a Cisco platform API that could allow unauthorized access to sensitive data. The developer is aware of the organization's established security incident reporting procedures and Cisco's official channels for vulnerability disclosure. The developer is considering bypassing these formal channels to implement a quick fix directly in the production environment to immediately mitigate the risk. What is the most appropriate course of action for the developer? Option A. Publicly disclose the vulnerability on a security forum to alert the wider community and pressure Cisco into a faster fix. Option B. Immediately implement a direct code change in the production environment to patch the vulnerability, as this is the fastest way to protect the data. Option C. Document the vulnerability but take no immediate action, assuming the risk is low, and it will be addressed in a future release cycle. Option D. Report the vulnerability through the organization's internal security incident reporting channels and Cisco's official vulnerability disclosure program, and await their guidance and remediation plan. The correct answer is D. Report the vulnerability through the organization's internal security incident reporting channels and Cisco's official vulnerability disclosure program, and await their guidance and remediation plan. Explanation. Scenario analysis. This scenario presents a professional challenge where a developer discovers a potential security vulnerability in a Cisco platform API that could be exploited. The challenge lies in balancing the immediate need to address the vulnerability with the established processes for reporting and remediation, while also considering the potential impact on the organization and its customers. The developer is faced with an ethical dilemma: to bypass official channels for a quicker fix, potentially causing unintended consequences or violating policy, or to follow protocol, which might delay remediation. This requires careful judgment to determine the most responsible and ethical course of action. Correct approach analysis. The correct approach involves reporting the vulnerability through the established internal channels and Cisco's official security vulnerability reporting process. This represents best professional practice because it adheres to organizational policies and industry best practices for security incident management. It ensures that the vulnerability is documented, assessed by the appropriate security teams, and remediated in a controlled and coordinated manner. This process minimizes the risk of introducing new vulnerabilities or causing service disruptions through an unvetted fix. It also aligns with ethical obligations to protect the organization and its users from harm by ensuring a thorough and secure resolution. Incorrect approaches analysis. One incorrect approach is to attempt to fix the vulnerability directly in the production environment without proper authorization or testing. This is a significant regulatory and ethical failure. It bypasses established change management processes, which are in place to prevent unintended consequences and ensure system stability. It also violates the principle of responsible disclosure and could lead to a breach of trust with Cisco and potentially expose the organization to legal liabilities if the unauthorized change causes damage or data loss. Another incorrect approach is to disclose the vulnerability publicly without first notifying Cisco and allowing them a reasonable time to address it. This is a violation of responsible disclosure principles and ethical conduct. Public disclosure without prior notification can put users at immediate risk before a fix is available, potentially leading to widespread exploitation and significant harm. It also undermines the collaborative efforts between developers and vendors to maintain secure systems. A third incorrect approach is to ignore the vulnerability, assuming it is minor or unlikely to be exploited. This is a failure of professional responsibility and an ethical lapse. Developers have a duty to identify and report potential security risks, regardless of their perceived severity. Ignoring a known vulnerability, even if it seems low risk, can have severe consequences if it is eventually exploited, leading to data breaches, financial losses, and reputational damage. Professional reasoning. Professionals in this situation should follow a structured decision-making process. First, they should thoroughly document the discovered vulnerability, including its potential impact and how it was identified. Second, they should consult their organization's internal security policies and incident response plan to understand the proper reporting procedures. Third, they should initiate the reporting process through the designated internal channels, ensuring all relevant information is provided. Simultaneously, they should investigate Cisco's official channels for reporting security vulnerabilities and follow their guidelines. Throughout this process, maintaining clear communication with relevant stakeholders, including security teams and management, is crucial. This systematic approach ensures that vulnerabilities are handled professionally, ethically, and in compliance with all applicable regulations and best practices. Question 10. Strategic planning requires a robust approach to managing sensitive API credentials when developing applications that integrate with Cisco core platforms. Considering the need for secure and auditable access, which method best aligns with industry best practices and regulatory expectations for protecting authentication information? Option A. Placing API credentials in plain text within application configuration files stored in a publicly accessible version control repository. Option B. Storing API credentials in a dedicated enterprise-grade secrets management solution with granular access controls and audit logging. Option C. Embedding API credentials directly within the application source code, protected by basic encryption. Option D. Utilizing environment variables on the application server to store API credentials without further access restrictions. Correct answer is B. Storing API credentials in a dedicated enterprise-grade secrets management solution with granular access controls and audit logging. Explanation. Scenario analysis. This scenario presents a professional challenge rooted in the responsible development and deployment of network automation solutions. The core difficulty lies in balancing the drive for innovation and efficiency with the imperative to maintain robust security postures and adhere to established operational guidelines. Developers must navigate the complexities of integrating new API-driven functionalities into existing Cisco infrastructure without introducing vulnerabilities or disrupting critical services. This requires a deep understanding of both the application development lifecycle and the security implications of API interactions within a regulated enterprise environment. Careful judgment is needed to select the most secure and compliant method for managing API credentials, ensuring that sensitive information is protected and access is appropriately controlled. Correct approach analysis. The correct approach involves utilizing a dedicated secrets management solution, such as Cisco Key Management, HashiCorp Vault, or a similar enterprise-grade tool, to store and retrieve API credentials. This represents best professional practice because it aligns with fundamental security principles and regulatory requirements for data protection and access control. Secrets management solutions are designed to securely store, manage, and audit access to sensitive information like API keys and passwords. They enforce granular access policies, facilitate credential rotation, and provide audit trails, which are crucial for compliance with security standards and internal policies. This method minimizes the risk of hard-coding credentials, which is a significant security vulnerability, and ensures that credentials are not exposed in source code repositories or configuration files accessible to unauthorized personnel. This directly addresses the need for secure credential handling, as mandated by general IT security best practices, and often implicitly required by compliance frameworks that emphasize data confidentiality and integrity. Incorrect approaches analysis. Storing API credentials directly within the application's source code, even if encrypted with a simple algorithm, represents a significant regulatory and ethical failure. This practice, often referred to as hard-coding, makes credentials vulnerable to exposure if the source code is compromised, leaked, or accessed by unauthorized individuals. Many data protection regulations, such as those governing personally identifiable information, PI, or financial data, mandate strong controls over access to sensitive credentials. Hard-coding bypasses these controls, increasing the likelihood of a data breach and potential noncompliance with data privacy laws. Embedding API credentials within application configuration files that are not adequately secured or are stored in version control systems without proper access restrictions is another failure. Configuration files, especially those in plain text or easily accessible locations, are common targets for attackers. If these files contain credentials, an attacker gaining access to them can immediately compromise the integrated systems. This violates the principle of least privilege and fails to implement adequate safeguards for sensitive information, which is a common requirement in security audits and compliance assessments. Using environment variables to store API credentials, while better than hard coding, can still pose risks if not managed properly. Environment variables are accessible to any process running under the same user account. If the server or container hosting the application is compromised, these credentials can be exposed. Furthermore, in shared environments or container orchestration platforms, Managing and isolating environment variables securely across different applications and teams requires careful configuration and can be prone to misconfiguration, leading to unintended access. This approach lacks the centralized control, auditing, and automated rotation capabilities offered by dedicated secrets management solutions, making it less robust from a security and compliance perspective. Professional reasoning. When developing applications that interact with core platforms via APIs, professionals must adopt a security-first mindset. The decision-making process should prioritize methods that minimize the attack surface and ensure compliance with security policies and relevant regulations. This involves 1. Identifying all sensitive credentials required for API authentication. 2. Evaluating different credential management strategies based on security, scalability, and auditability. 3. Prioritizing solutions that offer centralized management, granular access control, automated rotation, and comprehensive auditing capabilities. 4. Consulting with security teams and compliance officers to ensure the chosen approach meets all organizational and regulatory requirements. 5. Documenting the chosen approach and its rationale thoroughly. Question 11. Research into the integration of a new third-party API for network telemetry into an existing Cisco network infrastructure reveals potential benefits for real-time monitoring. What is the most critical step to ensure this integration does not negatively impact network stability, security, or data integrity? Option A. Focus solely on the technical implementation details of the API, ensuring it can connect to the Cisco platform without further investigation into its broader implications. Option B. Proceed with the integration immediately, assuming the API's documentation guarantees compatibility and minimal disruption. Option C. Conduct a comprehensive impact assessment that evaluates the API's effect on existing systems, data flows, security protocols, and operational procedures, and develop mitigation strategies. Option D. Rely on the vendor's assurance that the API is secure and has been used successfully in other environments without performing an independent assessment. The correct answer is C. Conduct a comprehensive impact assessment that evaluates the API's effect on existing systems, data flows, security protocols, and operational procedures, and develop mitigation strategies. Explanation. This scenario presents a professional challenge due to the inherent risks associated with integrating new technologies into existing critical infrastructure. The need to balance innovation with the imperative of maintaining service continuity and data integrity requires a rigorous and systematic approach. The professional challenge lies in anticipating potential negative impacts, both technical and operational, before deployment, thereby mitigating risks to the organization and its stakeholders. Careful judgment is required to ensure that the pursuit of enhanced functionality does not compromise established security protocols or regulatory compliance. The correct approach represents best professional practice because it prioritizes a comprehensive impact assessment. This involves a thorough evaluation of how the proposed API integration might affect existing systems, data flows, security postures, and user experience. By systematically identifying potential risks and vulnerabilities and developing mitigation strategies, this approach ensures that the integration is performed in a controlled and secure manner. This aligns with the principles of responsible technology adoption and risk management, which are implicitly expected within the professional context of developing applications on Cisco core platforms, where reliability and security are paramount. While specific regulations for the DEVCOR exam are not explicitly stated as a jurisdiction, the professional standards and ethical considerations inherent in IT development and deployment, particularly within enterprise environments that Cisco platforms serve, mandate such due diligence. An incorrect approach that focuses solely on the technical feasibility of the API integration, without considering its broader impact, represents a significant regulatory and ethical failure. This oversight can lead to unforeseen system failures, data breaches, or service disruptions, which could have severe financial and reputational consequences for the organization. Furthermore, it demonstrates a lack of due diligence and a failure to adhere to professional standards of care expected in application development. Another incorrect approach that neglects to involve relevant stakeholders, such as security teams or operations personnel, in the assessment process is also professionally unacceptable. This siloed approach can result in critical blind spots, as the unique perspectives and expertise of different departments are not leveraged. This can lead to the overlooking of crucial security vulnerabilities or operational incompatibilities, thereby increasing the likelihood of negative impacts. Ethically, it represents a failure to collaborate and communicate effectively, which are essential for successful project outcomes. A third incorrect approach that relies on anecdotal evidence or the assumption that it worked elsewhere, without a tailored assessment for the specific environment, is professionally unsound. Each network and application environment has unique characteristics and configurations. What may be successful in one context may introduce significant risks in another. This approach demonstrates a lack of critical thinking and a failure to apply a systematic, evidence-based methodology, which is a cornerstone of professional IT practice. The professional decision-making process for similar situations should involve a structured risk assessment framework. This begins with clearly defining the scope of the proposed change. Next, potential impacts across technical, operational, security, and compliance domains must be identified. For each identified impact, the likelihood and severity of its occurrence should be evaluated. Based on this evaluation, mitigation strategies should be developed and prioritized. Finally, a plan for monitoring and reassessment post-implementation should be established. This iterative and comprehensive process ensures that technology adoption is both innovative and responsible. Question 12. Quality control measures reveal a potential security vulnerability in a newly developed Cisco application designed to process sensitive customer financial data. The development team has identified a specific weakness that could allow unauthorized access to this data. What is the most appropriate next step to ensure compliance with industry best practices and the implicit regulatory framework governing application development within the DEVCOR exam scope? Option A. Immediately deploy a patch to address the identified weakness without further analysis. Option B. Document the vulnerability and defer remediation until the next scheduled maintenance cycle. Option C. Initiate a formal risk assessment process to identify, analyze, and evaluate the vulnerability and its potential impact. Option D. Rely on the application's existing security features to mitigate the risk of exploitation. The correct answer is C. Initiate a formal risk assessment process to identify, analyze, and evaluate the vulnerability and its potential impact. Explanation. Scenario analysis. This scenario presents a professional challenge because the development team has identified a potential security vulnerability in an application that interacts with sensitive customer data. The challenge lies in balancing the urgency of addressing the vulnerability with the need for a thorough and compliant risk assessment process. Rushing the assessment could lead to overlooking critical risks, while an overly protracted process could expose the application and its users to ongoing threats. The team must navigate this tension while adhering to the specific regulatory framework governing the development and deployment of applications within the Cisco ecosystem, as defined by the 350-901 DEVCOR exam scope. This requires a structured approach that prioritizes data protection and system integrity. Correct approach analysis. The correct approach involves conducting a comprehensive risk assessment that systematically identifies, analyzes, and evaluates the identified vulnerability. This process should involve understanding the potential impact of the vulnerability on the confidentiality, integrity, and availability of the data, as well as the likelihood of exploitation. Based on this analysis, appropriate mitigation strategies should be developed and prioritized. This aligns with best professional practices by ensuring that security decisions are data-driven and proportionate to the identified risks. Adherence to the principles of secure development lifecycle (SDLC) and relevant Cisco guidelines, which are implicitly part of the DEVCOR exam's jurisdiction, mandates such a structured and documented approach to security incident response and risk management. This ensures accountability and provides a clear audit trail. Incorrect approach is analysis. One incorrect approach would be to immediately deploy a patch without a formal risk assessment. This bypasses the critical step of understanding the full scope of the vulnerability and its potential impact, potentially leading to unintended consequences or the introduction of new vulnerabilities. This is a regulatory and ethical failure because it demonstrates a disregard for due diligence in protecting user data and system stability, violating principles of responsible software development. Another incorrect approach would be to ignore the vulnerability due to perceived low likelihood of exploitation. This is a significant regulatory and ethical failure. It demonstrates negligence in fulfilling the duty of care to protect sensitive data and systems. The potential for even a low-likelihood event to cause substantial damage, coupled with the expectation of proactive security measures within the DEVCOR framework, makes this approach unacceptable. A third incorrect approach would be to implement a quick fix that addresses the immediate symptom, but not the root cause of the vulnerability. This is professionally unsound and ethically questionable, as it creates technical debt and leaves the system susceptible to future attacks exploiting the underlying flaw. It fails to meet the standard of robust security engineering expected within the DEVCOR exam's context. Professional reasoning. Professionals should approach such situations by first acknowledging the identified issue and initiating a formal incident response process. This process should include a structured risk assessment, which involves defining the scope, identifying assets at risk, analyzing threats and vulnerabilities, evaluating the likelihood and impact of potential incidents, and determining the overall risk level. Following the assessment, mitigation strategies should be developed, implemented, and tested. Documentation throughout this process is crucial for accountability, compliance, and continuous improvement. This systematic and documented approach ensures that decisions are informed, defensible, and aligned with professional and regulatory expectations. Question 13. Quality control measures reveal that a new application designed to integrate with Cisco core platforms and APIs collects user activity data for performance monitoring and troubleshooting. The development team has implemented standard security protocols, but has not explicitly consulted with legal counsel regarding data privacy regulations specific to the jurisdiction where the application will be deployed. Which of the following approaches best ensures regulatory compliance and professional responsibility? Option A. Proceed with the current implementation, assuming that general security best practices are sufficient to meet all regulatory obligations for data privacy. Option B. Conduct a thorough review of applicable data privacy laws in the deployment jurisdiction. Consult with legal counsel to understand specific requirements for data collection, consent, and user rights, and integrate these findings into the application's design and data handling policies. Option C. Focus solely on the functional requirements of the application, deferring any data privacy considerations until a specific regulatory inquiry or complaint is received. Option D. Implement additional encryption and access controls as a post-development measure to address potential privacy concerns that may arise. The correct answer is B. Conduct a thorough review of applicable data privacy laws in the deployment jurisdiction. Consult with legal counsel to understand specific requirements for data collection, consent, and user rights, and integrate these findings into the application's design and data handling policies. Explanation. Scenario analysis. This scenario presents a professional challenge related to the development of applications interacting with Cisco core platforms and APIs, specifically concerning the regulatory compliance of data handling. The challenge lies in ensuring that the application's data collection and processing mechanisms adhere to the relevant data privacy regulations within the specified jurisdiction. Developers must balance the functional requirements of the application with the legal obligations to protect user data, which requires a thorough understanding of the applicable laws and how they translate into technical implementation. The need for robust security measures and transparent data handling practices adds further complexity. Correct approach analysis. The correct approach involves proactively identifying and integrating data privacy requirements into the application's design and development lifecycle from the outset. This aligns with the principles of privacy by design and by default, which are foundational to many data protection regulations. By consulting with legal counsel and data privacy experts, and by implementing technical controls such as data minimization, encryption, and access controls, the development team ensures that the application not only meets functional objectives, but also complies with legal mandates. This approach minimizes the risk of regulatory penalties, reputational damage, and loss of user trust. It demonstrates a commitment to responsible data stewardship, which is a key ethical and professional standard. Incorrect approaches analysis. Implementing data collection features without a clear understanding of the regulatory landscape and user consent requirements constitutes a significant regulatory failure. This approach risks collecting sensitive data unlawfully, leading to potential fines and legal action. Retrofitting security and privacy controls after the application has been developed and deployed is a reactive and often ineffective strategy. This approach is prone to overlooking critical vulnerabilities and may not fully address the spirit or letter of the law, resulting in non-compliance and increased remediation costs. Assuming that general security best practices are sufficient without specific consideration for data privacy regulations is an ethical and regulatory oversight. While security is important, it does not automatically equate to privacy compliance. Specific regulations often mandate particular data handling procedures, consent mechanisms, and data subject rights that general security measures may not cover. Professional reasoning. Professionals developing applications that handle data must adopt a proactive and compliance-first mindset. The decision-making process should involve 1. Understanding the applicable regulatory framework for the target jurisdiction. 2. Identifying all data types that will be collected, processed, and stored. 3. Assessing the sensitivity of the data and associated privacy risks. 4. Integrating privacy and security requirements into the design and architecture from the earliest stages. 5. Implementing technical and organizational measures to ensure compliance. 6. Establishing clear data governance policies and procedures. 7. Regularly reviewing and updating practices to adapt to evolving regulations and threats. 8. Seeking expert advice from legal and privacy professionals when necessary. Question 14. Which approach would be most effective in developing a Cisco network automation application that securely retrieves and modifies device configurations via REST APIs, while adhering to best practices for application security and data integrity? Option A. Use a single, shared set of API credentials for all users of the application to simplify management and bypass input validation to improve API response times. Option B. Rely solely on the default authentication mechanisms provided by the Cisco devices themselves, without implementing additional application-level security checks, and assume API inputs will be valid. Option C. Implement robust authentication and authorization at the API gateway, enforce granular access controls within the application logic based on user roles, and perform thorough input validation and sanitization for all data sent to the Cisco APIs. Option D. Develop the application with minimal security considerations, focusing primarily on rapid feature development, and plan to address security vulnerabilities only if they are discovered during testing. The correct answer is C. Implement robust authentication and authorization at the API gateway, enforce granular access controls within the application logic based on user roles, and perform thorough input validation and sanitization for all data sent to the Cisco APIs. Explanation. This scenario presents a common challenge in developing applications that interact with Cisco core platforms and APIs, ensuring that the application's design and implementation adhere to best practices for security and data integrity, particularly when dealing with sensitive network configurations. The professional challenge lies in balancing the need for efficient API utilization with the imperative to prevent unauthorized access or accidental misconfiguration. Careful judgment is required to select an approach that minimizes risk while maximizing functionality. The correct approach represents best professional practice because it prioritizes a layered security model and robust validation mechanisms. By implementing authentication and authorization at the API gateway, and further enforcing granular access controls within the application logic, it ensures that only legitimate users with appropriate permissions can interact with the network devices. Input validation and sanitization are critical to prevent injection attacks and ensure that data sent to the API is in the expected format, thereby maintaining the integrity of the network configuration. This aligns with general principles of secure software development and the implicit requirements for responsible API usage within any enterprise environment, aiming to prevent breaches and maintain operational stability. An incorrect approach that bypasses or inadequately implements authentication and authorization mechanisms creates significant regulatory and ethical failures. It exposes the network to unauthorized access, potentially leading to data breaches, service disruptions, or even complete compromise of the network infrastructure. This directly violates the implicit duty of care to protect sensitive network data and maintain system security, which could have severe legal and financial repercussions for the organization. Furthermore, an approach that neglects input validation and sanitization is ethically unsound, as it knowingly introduces vulnerabilities that could be exploited by malicious actors, demonstrating a disregard for the security and stability of the network and its users. The professional reasoning process for similar situations should involve a thorough risk assessment of the application's intended functionality and the data it will access or modify. Developers should consult relevant security guidelines and best practices for API development and network management. Prioritizing security from the outset rather than as an afterthought is crucial. This involves designing for least privilege, implementing comprehensive logging and auditing, and conducting regular security testing. When in doubt, consulting with security professionals or adhering to established security frameworks is a prudent decision-making step. Question 15. The review process indicates that a new application leveraging Cisco core platforms and APIs is nearing its deployment deadline. The development team has focused primarily on feature functionality and performance optimization, with security considerations being addressed only in the final testing phase. Which approach best aligns with professional best practices for developing secure applications in this context? Option A. Prioritize completing all planned features and then schedule a single, comprehensive security audit immediately before deployment. Option B. Conduct comprehensive threat modeling and security design reviews during the initial planning and design phases, and integrate security testing throughout the development lifecycle, including code reviews and penetration testing. Option C. Implement automated security scanning tools at the end of the development cycle and address any critical findings before deployment. Option D. Rely on the inherent security features of the Cisco core platforms and APIs, assuming that their use will automatically secure the application. The correct answer is B. Conduct comprehensive threat modeling and security design reviews during the initial planning and design phases, and integrate security testing throughout the development lifecycle, including code reviews and penetration testing. Explanation. Scenario analysis. This scenario presents a professional challenge rooted in the inherent tension between rapid development cycles and robust security practices within the context of Cisco's core platforms and APIs. Developers are tasked with delivering new features quickly, but this urgency can lead to overlooking critical security considerations, especially when dealing with sensitive data or access controls. The challenge lies in balancing the business need for speed with the regulatory and ethical imperative to protect data and system integrity. The use of APIs, while enabling integration and automation, also introduces potential attack vectors if not properly secured. Correct approach analysis. The correct approach emphasizes a proactive and integrated security posture throughout the development lifecycle. This aligns with the principles of secure software development, which are implicitly expected within the regulatory framework governing technology development and data handling. By incorporating security reviews and threat modeling early in the design phase, potential vulnerabilities are identified and mitigated before they become deeply embedded in the code. This approach demonstrates due diligence and a commitment to responsible development, minimizing the risk of data breaches, unauthorized access, and compliance violations. It reflects best professional practice by prioritizing security as a fundamental requirement, not an afterthought, thereby safeguarding both the organization and its users. Incorrect approaches analysis. One incorrect approach involves deferring security testing until the final stages of development. This is a significant regulatory and ethical failure because it increases the likelihood of discovering critical vulnerabilities late in the process, leading to costly delays, potential rework, and a higher risk of deploying insecure code. It suggests a lack of foresight and a reactive rather than proactive security mindset, which can be seen as negligent in the context of data protection regulations. Another incorrect approach is to rely solely on automated security scanning tools without human oversight or manual penetration testing. While automation is valuable, it cannot replace the nuanced understanding and creative thinking of security professionals who can identify complex, context-dependent vulnerabilities that tools might miss. This approach risks a false sense of security and can lead to the deployment of applications with exploitable weaknesses, violating the principle of providing secure services. A third incorrect approach is to assume that using Cisco's core platforms and APIs inherently guarantees security. While Cisco provides robust security features, the responsibility for secure implementation and configuration ultimately lies with the developer. Over-reliance on platform security without understanding and applying secure coding practices for API interactions is a critical oversight. This can lead to misconfigurations or insecure custom logic that exposes the application and its data, failing to meet the expected standard of care. Professional reasoning. Professionals should adopt a risk-based decision-making framework that integrates security considerations from the outset. This involves 1. Threat modeling, identifying potential threats and vulnerabilities early in the design phase. 2. Secure design principles, incorporating security into the architecture and design of the application. 3. Secure coding practices, adhering to established guidelines for writing secure code, especially when interacting with APIs. 4. Continuous security testing, implementing a combination of automated and manual testing throughout the development lifecycle. 5. Security reviews, conducting regular reviews by security experts to validate security controls. This systematic approach ensures that security is a continuous concern, leading to more robust and compliant applications. Question 16. The analysis reveals that a newly developed application interacting with Cisco core platforms is experiencing performance degradation during peak usage periods, impacting user experience and data processing throughput. The development team is tasked with optimizing the application's process flow to mitigate these issues. Which of the following strategies best aligns with professional best practices for process optimization in this context? Option A. Immediately implement aggressive caching mechanisms across all data retrieval points to reduce the load on backend systems, assuming this will universally improve performance. Option B. Conduct a detailed profiling of the application's execution to identify specific code sections and API calls that are consuming excessive resources or introducing latency, and then implement targeted optimizations in those areas. Option C. Increase the allocated compute resources for the application's hosting environment without investigating the root cause of the performance bottleneck. Option D. Refactor the entire application architecture to a microservices model, believing that a complete overhaul will inherently resolve any performance issues. The correct answer is B. Conduct a detailed profiling of the application's execution to identify specific code sections and API calls that are consuming excessive resources or introducing latency, and then implement targeted optimizations in those areas. Explanation. This scenario presents a common challenge in developing applications for Cisco core platforms, optimizing process efficiency without compromising security or compliance. The professional challenge lies in balancing the need for speed and resource utilization with the imperative to adhere to established security protocols and data handling regulations. Careful judgment is required to select an optimization strategy that aligns with the specific requirements of the DEVCOR exam's regulatory framework, which implicitly emphasizes secure and compliant development practices. The correct approach represents best professional practice because it prioritizes a thorough understanding of the existing process and its potential bottlenecks before implementing changes. This aligns with a principle of responsible development, ensuring that optimizations are targeted, effective, and do not introduce unintended consequences. By focusing on identifying and addressing specific inefficiencies, this approach minimizes risk and maximizes the likelihood of a successful outcome. Furthermore, it implicitly supports the regulatory expectation of developing robust and reliable applications, which are less prone to errors and security vulnerabilities. An incorrect approach that focuses solely on aggressive resource allocation without understanding the underlying process is professionally unacceptable. This could lead to inefficient use of resources, increased operational costs, and potentially introduce instability or security flaws by bypassing necessary validation or error handling steps. Such an approach would violate the implicit regulatory expectation of developing secure and efficient applications, as it prioritizes speed over a well-understood and controlled implementation. Another incorrect approach that involves implementing a one-size-fits-all optimization solution without considering the specific context of the application and its data flows is also professionally flawed. This demonstrates a lack of due diligence and can lead to suboptimal performance or even functional failures. It disregards the principle of tailoring solutions to specific needs, which is a cornerstone of effective application development and implicitly expected by regulatory frameworks that demand functional integrity. The professional reasoning process for similar situations should involve a systematic evaluation of the current state, identification of specific pain points, exploration of potential solutions with a focus on their impact on efficiency, security, and compliance, and a phased implementation with rigorous testing. Professionals should always ask, does this change improve efficiency without negatively impacting security or compliance? And is this change based on a clear understanding of the process being optimized? Question 17. Governance review demonstrates that a development team is proposing significant changes to an existing API that handles sensitive customer data. The team believes these changes are necessary to enable new application features and are eager to deploy them quickly. What is the most appropriate approach to ensure the changes are implemented securely and in compliance with relevant regulations? Option A. Proceed with the API changes based on the development team's assessment of functional requirements and rely on post-deployment monitoring to identify any security or compliance issues. Option B. Perform a limited impact assessment focusing only on the direct technical implications of the API changes without engaging security or compliance teams. Option C. Implement the API changes immediately to meet business demands and address any identified security or compliance concerns as they arise through ad hoc fixes. Option D. Conduct a thorough impact assessment that evaluates the potential effects on data security, user privacy, system integrity, and regulatory compliance, involving relevant stakeholders before proceeding with development and deployment. The correct answer is D. Conduct a thorough impact assessment that evaluates the potential effects on data security, user privacy, system integrity, and regulatory compliance, involving relevant stakeholders before proceeding with development and deployment. Explanation. Scenario analysis. This scenario presents a common challenge in software development within regulated environments, balancing the need for rapid feature deployment with the imperative of maintaining robust security and compliance. The pressure to deliver new functionality quickly can lead to shortcuts in the impact assessment process, potentially introducing vulnerabilities or non-compliance risks that could have significant financial and reputational consequences. The professional challenge lies in advocating for and implementing a thorough impact assessment process that is integrated into the development lifecycle, rather than being an afterthought. This requires effective communication with stakeholders, demonstrating the value of proactive risk management, and understanding the specific regulatory landscape governing the application's use. Correct approach analysis. The correct approach involves a comprehensive impact assessment that systematically evaluates the potential effects of the proposed API changes on existing systems, data security, user privacy, and regulatory compliance. This assessment should be conducted early in the development lifecycle, involving relevant stakeholders from security, compliance, and operations teams. The goal is to identify potential risks, such as data breaches, unauthorized access, or noncompliance with data handling regulations, and to define mitigation strategies before the API is deployed. This proactive approach aligns with best practices in secure software development and regulatory adherence, ensuring that the application remains compliant and secure throughout its lifecycle. By integrating impact assessment into the development process, organizations can prevent costly remediation efforts and maintain trust with their users and regulators. Incorrect approaches analysis. One incorrect approach is to proceed with the API changes based solely on the development team's understanding of the immediate functional requirements, without a formal impact assessment. This fails to consider broader implications, such as how the changes might affect data integrity, introduce new attack vectors, or violate existing data privacy regulations. This oversight can lead to significant security vulnerabilities and regulatory noncompliance, potentially resulting in fines, legal action, and reputational damage. Another incorrect approach is to conduct a superficial impact assessment that only considers the direct technical impact on the API itself, neglecting the downstream effects on integrated systems, user experience, or compliance obligations. This limited scope means that critical risks related to data leakage, unauthorized access to sensitive information, or failure to meet reporting requirements under relevant regulations might be missed. Such an assessment is insufficient for ensuring the overall security and compliance posture of the application. A third incorrect approach is to defer the impact assessment until after the API has been deployed, relying on post-deployment monitoring to identify issues. While monitoring is important, It is a reactive measure. Waiting until after deployment to assess impact means that any vulnerabilities or compliance gaps are already in production, increasing the likelihood of exploitation or regulatory violation before they can be addressed. This approach is inherently riskier and more costly to remediate than a proactive assessment. Professional reasoning. Professionals should adopt a risk-based approach to software development, where impact assessment is a mandatory and integral part of the development lifecycle. This involves establishing clear policies and procedures for conducting thorough impact assessments for all significant changes, including API modifications. Key steps include: 1. Early identification. Integrate impact assessment into the initial design and planning phases. 2. Cross-functional collaboration. Involve security, compliance, legal, and operations teams to ensure all potential impacts are considered. 3. Comprehensive scope. Assess technical, security, privacy, operational, and regulatory compliance impacts. 4. Risk mitigation. Develop and implement concrete plans to address identified risks. 5. Documentation and review. Maintain detailed records of the assessment and mitigation efforts, and ensure regular review and updates. This structured approach ensures that development efforts are aligned with organizational security and compliance objectives, fostering a culture of responsible innovation. Question 18. Cost-benefit analysis shows that integrating a third-party API for enhanced customer analytics offers significant advantages in terms of feature development speed and competitive positioning. However, the API's data handling practices are not fully transparent, and the organization operates under a strict regulatory framework that mandates specific data privacy and security controls for customer information. Which approach best balances innovation with regulatory compliance? Option A. Delay the integration until the third-party vendor provides exhaustive, independently verified proof of compliance with all relevant data privacy laws, even if this significantly impacts the development timeline. Option B. Proceed with the integration after a thorough review of the API's documentation and a risk assessment to identify and mitigate potential compliance gaps, ensuring the integration adheres to all applicable data privacy and security regulations. Option C. Integrate the API and address any potential compliance issues that arise post-deployment through reactive measures and updates. Option D. Prioritize the rapid integration of the API to gain a competitive edge, assuming that existing organizational compliance measures will adequately cover the new data flows. The correct answer is B. Proceed with the integration after a thorough review of the API's documentation and a risk assessment to identify and mitigate potential compliance gaps, ensuring the integration adheres to all applicable data privacy and security regulations. Explanation. This scenario presents a professional challenge because it requires balancing the immediate benefits of a new API integration with the long-term implications of regulatory compliance and data privacy. The core tension lies in the potential for rapid development and feature enhancement versus the risk of inadvertently violating data handling regulations. Careful judgment is required to ensure that the pursuit of innovation does not compromise legal obligations or user trust. The correct approach represents best professional practice because it prioritizes a thorough understanding and adherence to the regulatory framework governing data handling and API usage. By conducting a comprehensive risk assessment and ensuring all integrations are designed with privacy by design principles, the development team proactively mitigates potential compliance issues. This aligns with the ethical imperative to protect user data and maintain legal standing, which are fundamental to sustainable business operations and professional integrity. An incorrect approach that focuses solely on speed and ignores regulatory review risks significant legal and financial penalties. This failure stems from a disregard for the specific requirements of the relevant regulatory framework, which mandates due diligence in data processing and API interactions. Another incorrect approach, which assumes existing compliance measures are sufficient without specific validation for the new API, demonstrates a lack of professional rigor and an over-reliance on assumptions. This can lead to unforeseen gaps in compliance, exposing the organization to breaches and regulatory scrutiny. A third incorrect approach, which delays addressing potential compliance concerns until after deployment, is fundamentally reactive and places the organization in a precarious position, potentially requiring costly remediation and facing reputational damage. Professionals should employ a decision-making framework that integrates regulatory considerations from the outset of any development project. This involves establishing clear compliance checkpoints, engaging legal and compliance teams early, and fostering a culture where regulatory adherence is seen as an enabler of responsible innovation, not a hindrance. When faced with choices, professionals should ask, does this approach demonstrably meet all applicable regulatory requirements? What are the potential downstream compliance risks? Is there a more robust, albeit potentially slower, method that ensures long-term adherence? Question 19. During the evaluation of a new third-party API for integration into a critical business application, a development team is presented with two options. Option A offers advanced features that significantly accelerate development, but has limited publicly available security documentation. Option B provides robust security features and clear documentation on its compliance with industry security standards, though its feature set is slightly less comprehensive and may require additional development effort to achieve the desired functionality. The team is under pressure to meet a tight deadline. Which approach best aligns with professional development best practices for application security? Option A. Prioritize the API with comprehensive security features and clear documentation, even if it requires additional development effort to ensure the application's integrity and data protection. Option B. Select the API with advanced features that accelerate development, assuming the risk of limited security documentation is acceptable given the project deadline. Option C. Focus solely on the API's feature set and performance metrics, deferring any security considerations until after the application is deployed. Option D. Integrate both APIs to leverage the advanced features of one and the security of the other, without a thorough security review of the combined integration. The correct answer is A. Prioritize the API with comprehensive security features and clear documentation, even if it requires additional development effort, to ensure the application's integrity and data protection. Explanation. This scenario presents a professional challenge due to the inherent tension between rapid development timelines and the critical need for robust security practices when integrating third-party APIs. Developers must make informed decisions about API selection and integration, balancing functionality with potential security risks. The DEVCOR exam emphasizes understanding how to build secure and reliable applications, which includes evaluating external dependencies. The correct approach represents best professional practice because it prioritizes a thorough, risk-based assessment of the third-party API's security posture before integration. This aligns with general principles of secure software development and the implicit responsibility to protect user data and application integrity. By verifying compliance with industry-standard security protocols, e.g., OAuth 2, 0 for authorization, TLS for data in transit, and reviewing the API provider's security documentation and certifications, developers mitigate potential vulnerabilities. This proactive stance is crucial for maintaining trust and avoiding costly security breaches, which are implicitly governed by the need for due diligence in software development. An incorrect approach that bypasses security vetting of the third-party API is professionally unacceptable. This failure to perform due diligence constitutes a significant security risk. It can lead to the introduction of vulnerabilities into the application, potentially exposing sensitive data to unauthorized access or manipulation. Such negligence could be seen as a breach of professional responsibility to build secure systems and could have legal ramifications if data breaches occur. Even if not explicitly detailed in the DEVCOR syllabus, the underlying principle of responsible development is paramount. Another incorrect approach, focusing solely on the API's feature set without considering its security implications, is also professionally unsound. While functionality is important, it cannot come at the expense of security. Ignoring security requirements during the API selection process creates a direct pathway for potential exploits. This demonstrates a lack of understanding of the holistic nature of application development, where security is not an afterthought but an integral component. The professional reasoning process for similar situations should involve a structured decision-making framework. This framework begins with clearly defining the functional requirements. Subsequently, a comprehensive security assessment of potential API solutions must be conducted, including reviewing documentation, understanding authentication and authorization mechanisms, and evaluating data handling practices. A risk assessment should then be performed to weigh the benefits of integration against the identified security risks. Finally, a decision should be made based on a balance of functionality, security, and overall project risk tolerance, always erring on the side of caution when security is concerned. Question 20. Risk assessment procedures indicate that a new application leveraging Cisco core platforms and APIs for customer data management may inadvertently expose sensitive information due to a lack of integrated compliance validation during the development lifecycle. Which of the following approaches best mitigates the risk of regulatory noncompliance in this scenario, considering U.S. data privacy regulations? Option A. Conduct a comprehensive compliance audit only after the application has been fully deployed to production and has been operational for at least 3 months. Option B. Assume that the inherent security features of the Cisco core platforms and APIs used will automatically ensure compliance with all relevant U.S. data privacy regulations without additional developer effort. Option C. Implement automated compliance checks and security vulnerability scans as integral parts of the continuous integration and continuous deployment (CI/CD) pipeline, alongside mandatory security code reviews before each release. Option D. Assign the sole responsibility for ensuring regulatory compliance to the organization's dedicated security team, with minimal developer involvement in the compliance process. The correct answer is C. Implement automated compliance checks and security vulnerability scans as integral parts of the continuous integration and continuous deployment (CI/CD) pipeline, alongside mandatory security code reviews before each release. Explanation. Scenario analysis. This scenario presents a professional challenge in balancing the rapid deployment of new application features with the imperative of regulatory compliance within the context of developing applications using Cisco core platforms and APIs. The core tension lies in the potential for new functionalities to inadvertently introduce vulnerabilities or misconfigurations that could violate data privacy regulations, specifically those relevant to the U.S. jurisdiction, as implied by the DEVCOR exam's focus on common enterprise environments. Developers must exercise careful judgment to ensure that innovation does not come at the expense of security and compliance, which are non-negotiable aspects of responsible software development. Correct approach analysis. The correct approach emphasizes proactive integration of compliance checks and security best practices throughout the entire development lifecycle. This aligns with the principles of security by design and privacy by design, which are foundational to U.S. regulatory frameworks like HIPAA for healthcare data and GDPR. Though GDPR is EU, its principles are often adopted globally and are relevant to understanding robust data protection, and the DEVCOR exam context implies a need for broad applicability of secure development. By embedding automated compliance checks into the CI/CD pipeline and conducting thorough security reviews before deployment, organizations can significantly mitigate the risk of non-compliance. This approach demonstrates a commitment to due diligence and responsible data handling, which is a hallmark of professional best practice and a key expectation under U.S. data protection laws. It ensures that potential compliance issues are identified and remediated early, preventing costly breaches and reputational damage. Incorrect approaches analysis. One incorrect approach involves relying solely on post-deployment audits to identify compliance issues. This is a reactive strategy that fails to meet the proactive requirements of U.S. data privacy regulations. Such an approach creates a significant window of vulnerability where non-compliant applications can be actively processing sensitive data, leading to potential violations and penalties. It represents a failure in due diligence and a disregard for the principle of continuous compliance. Another incorrect approach is to defer compliance responsibilities entirely to a separate security or legal team without providing developers with the necessary tools, training, or integration points. This creates a disconnect and can lead to misinterpretations or delays. U.S. regulations often place a degree of responsibility on the development team to understand and implement compliance requirements. This approach fails to foster a culture of shared responsibility and can result in compliance being treated as an afterthought rather than an integral part of the development process. A third incorrect approach is to assume that using Cisco's core platforms and APIs inherently guarantees compliance. While Cisco provides robust security features, the responsibility for configuring and utilizing these platforms in a compliant manner rests with the application developer and the organization. Over-reliance on vendor-provided security without understanding the specific compliance obligations of the application's data and functionality is a critical ethical and regulatory failure. Professional reasoning. Professionals should adopt a risk-based approach to application development, integrating compliance and security considerations from the initial design phase through to deployment and ongoing maintenance. This involves 1. Understanding the specific regulatory landscape applicable to the data being processed and the application's intended use within the U.S. jurisdiction. 2. Implementing automated compliance checks and security scanning tools within the CI/CD pipeline. 3. Conducting regular security and compliance reviews with cross-functional teams. 4. Providing developers with ongoing training on relevant regulations and secure coding practices. 5. Establishing clear communication channels between development, security, and legal/compliance teams. 6. Prioritizing remediation of identified compliance and security risks before deployment.